Torngat Mountains National Park is in the Canadian low Arctic coastal region of northern Nunatsiavut, Labrador. We know that regional warming has resulted in local tundra greening and an increase in shrub density and height, but there is no information of the regional distribution of permafrost. This research is part of the Torngat Permafrost Project that began in order to characterize permafrost in the boundary of the Torngats. The four main objectives of this project are first, to establish a permafrost monitoring network, second, to enhance the existing ecological integrity monitoring initiatives in Torngats, third, to quantify potential impacts of shrub growth on permafrost, and fourth, to understand how permafrost thaw could impact the ecosystem and wildlife of the Torngats. Several field methods were used in order to investigate permafrost thickness, freeze-thaw depth, and the general distribution and shrub characteristics. This included conducting DC electrical resistivity tomography, also known as ERT, surveys over a total of 17 transects. Frost probing and/or instantaneous temperature profiling was done along most ERT transects, along with vegetative cover, density, and height shrub determinations in 1 meter square plots. Ground surface temperature loggers were also installed along the ERT transects. Ground surface temperature data was also compared to gridded daily air temperatures which covered the Torngat Mountains between 2010 and 2017, and these were generated from 13 climate stations which were established in the region. Finally, UAV images were also taken over the surveys. This project already has some preliminary findings. The first is a result of the field surveys, and these showed that tall shrubs, as you can see in the red square on the image, that they're associated with warmer ground temperatures and thinner permafrost. In contrast to this, prostrate shrubs, which are in the red square on the image, these are correlated with higher near-surface resistivities and detectable permafrost. The interactions that were seen between shrubs and permafrost, they seem to be influenced by the microclimate, surficial materials, and also where the field site is topographically located. In addition, the observed ground temperature warming that was seen beneath tall shrubs is thought to be associated with higher snow accumulation. Finally, the results from the ground surface temperature logger data analyses that allowed the estimation of permafrost presence suggest that 70 to 80% of the logger sites have permafrost present there. This is a really interesting result because it suggests that the regional distribution of permafrost in the Torngat Mountains is more likely extensive discontinuous rather than continuous that is usually depicted on permafrost maps. If you have any questions or if you want to discuss this research a little bit further, please feel free to contact the principal investigator, Dr. Robert Way, and his contact information is on the screen now. Thank you very much for listening.